Hello, this is Pratik Jaiswal, and this is my walkthrough and explanation of the task that was assigned to me. So I'll start with the problem statement. So the problem statement was I had two CSV files, which was holdings and trades. The task was to create a personalized track based LLM for chatbot for the business, which can answer any question from that CSV files. So this project solves a very common problem with LLM based analytical system, which is letting users ask natural language questions on structured financial data without uh, sacrificing safety or correctness. Also, I would like to state that this is not a free form chatbot and it is not a text to SQL. Instead, this is a controlled natural language query engine that provides questions into that converts questions into safe and executable Panda expressions. So I'll quickly go through the high level overview. So this system is works in four strict separated stages, which is schema grounding, normalization, rule based query planning, and safe execution. So we we'll start with the datas and things. So this is the uh, some like something some packages and dependencies which I had to install here. This is the configuration setup for this project. I went with GPT-4o mini. Any and You guys have to update your open API key and add it as a secret environment variable on your Google Colab to make this work. I am using GPT-4o mini. You guys can use anything. I have kept the temperature 0 because I didn't want our code to like our LLM to be creative. I wanted uh, strict control over it and zero creativity. Also had max tokens to 512 so that it doesn't get too creative in its answers and everything. And yeah, and this is the Python pandas version and everything, and this is just the defining the model. Then coming to here, I'm just loading the data, downloading it, storing it in holdings and trades data frame, and here I'm just going through the data. And then here, this is where my schema and normalization starts. So just removing all the white spaces and inconsistency formatting, basically preventing any issues that we might have with the namings of that headers. And then I am explicitly defining the schemas of holding schemas and trade schema. This is a key design decision here, um, and it is that the LLM never sees the raw data frame. Instead, it only sees what a human readable schema context, like from the context that I explicitly constructed. So this is where, so as of date, reporting date, holding, and so on and so forth. So basically, price, the latest market price per unit of the security used, PL, DTT, YTD, everything is defined here. So the idea was to eliminate hallucinating columns and force the planner to operate inside a closed word. Also, here is where I also defined no answer, which was asked in the question itself. So no answer found is, so this answer has to be returned. And then this is just some schema enforcements, so categorical columns, typing, basically working with the data and making sure that strict schemas are applied, schema rules are applied. And then here is the here is the admin prompt. The idea here is that uh, defining all the important parameters and all the important strict planners basically which is needed to be here. uh, so this planner operates under non-negotiable rules, basically defining which data frames are strictly allowed, which columns are allowed, that what is allowed, what is not allowed. Have also enforced a rule here that no user can override admin controls. So basically no one can override it. Have some explicit condition defined here. uh, as this as it was asked that only and only information from the tables have to be extracted, that has also been explicitly defined here. Group by features, ambiguity handling, multi-table rule, safety rules, execution rules, all the rules, all the admin rules are defined here. And then the two stage LLM design that I went with. The first stage that I went was with normalization. So the idea was it shouldn't generate code. Its only job is to rewrite vague natural language into a clear analytical uh, instruction. So basically the idea here is any query you pass into, so let's say you pass a query which is funds which is greater than X amount, so it should convert it into a readable panda query. In so if we have a funds price greater than that, it would convert it into this way. It creates it into a panda express. I explicitly mentioned that I don't want SQL because, as I told you, this is not a SQL problem statement. This is a pandas problem statement. And then second step was a strict planner. It must return only one panda express as expression, or none if no answers were found. Then I have also defined that the prompts shouldn't override anything. So strict forbidden tokens are explicitly mentioned, forbidden words are explicitly mentioned, and also allowed data frames are explicitly mentioned. So only those data frames uh, can go through or and process. Then I've added a synthesized layer. So basically here, this is where, if required, if necessary, the answer generated by the chatbot will be explained. Not every time this would be done. If it's actually required and it is in the context, within the context and within the problem statement of the given problem, then only it will synthesize, otherwise it won't. This is you'll note, this is so that instead of guessing, the system forces the user to ask, like, basically allows user to have stricter rules. And then I have some dummy questions from where from how you guys asked me to. So this is from the statement itself, I mean the PDF itself. I'll add another just to show you live. So print answer. uh, okay, this is AI suggestion, so we'll just go through this. Which fund has the lowest yearly profit? And it's saying that Co Yield 7 has the lowest. And let's go and ask something else. uh, Okay, so I have defined custodian name as well. So maybe if I ask something like Uh, what if I ask something like print answer, which what funds are managed by the custodian Belprime? And as you can see, the funds managed by custodian Belprime are uh, Grafield, Heather, and this. So basically, this is reading. So again, to summarize, what's happening is the way it is defined is it has two levels: admin level and user level. The admin rules are designed in such a way that users cannot override the admin rules. Then the allowed columns which the LLM uses to make any decisions are defined here. I have kept it smaller so that the so that to restrict hallucination and enforce stricter rules, so that none of the internet sources or information is used to answer any questions. This is intentional, the design is intentional, the enforcements are intentional. uh, the idea behind all this strict planning was to restrict hallucination and to stick to the uh, actual business use case. Uh, this was my attempt uh, for the LLM chatbot. Looking forward for the discussion with you guys regarding it. If you guys have any more questions, I can answer more questions. Uh, Also, one more thing I have to explicitly mention was intentionally. This is again a design decision that I have restricted two questions or two operations in one sentence questions. So if you are asking what is the minimum and maximum profit loss yearly for a particular stock, it won't, for a particular fund, it won't give you an answer because you are asking two expressions. If you ask a minimum and a maximum separately, it would work. So as a rule, it's one metric per time. This is only to restrict the hallucination, and to end it, it is not a demo chatbot, it is a control analytical query engine built with LLM to restrict any hallucination and stick to the business problem without any latency. Thank you so much.